Hello, welcome to One and All present here. Let us discuss about the plastics and polymer. The plastics and polymers today become an unavoidable material in our day-to-day life. So, we have to discuss about what is plastic, polymer, types of plastics and the difference between plastics and polymer, mechanical properties of plastics, then various utility of plastics, where the plastics are actually used. Without plastics, the survival of human life is a question mark. So let us discuss one by one. The word polymer is derived from the Greek roots poly and mer, which means poly, many, mer, parts. So polymer is many parts. The process through which polymers are produced from its monomer is known as polymerization. Example, polythene to polyvinyl chloride and nylon. Plastic is an organic high polymer. What is organic high polymer? Organic is a compound which contains carbon. Carbon compound molecules are called organic. So you must differentiate the organic and inorganic. So what is inorganic molecule? You know the normal salt, sodium chloride, we use it every day in our life. Hydrochloric acid, HCl. Sulfuric acid, H2SO4, aluminum sulfate. These molecules are called inorganic molecules. Why it is so? There is no carbon in these compounds, so they are called inorganic molecules. What about the organic molecule? You know the familiar example, acetic acid, CH3COOH, acetic acid, formic acid. Okay, we are very familiar with the inorganic compounds. Then organic compound, it must contain carbon atom. See acetic acid, CH3COOH. Formic acid. So formic acid, HCOOH, the normal glucose, C6H12O6. These compounds contain carbon atom. So they are called organic molecules, right? So now we will switch over to the plastic. Plastic is an organic high polymer. So I will give you the examples for the plastics. So normally we are using polythene. In our life, day-to-day life, everyone is using the polythene. So what is polythene? What is the molecular formula of polythene? Before that, you must know ethylene. What is the structure of ethylene? Ethylene, you know, this is an alkane. C double bond, CH2 double bond, CH2. This is ethylene. This is an organic compound, organic molecule. So this is ethylene. When you add one more ethylene, ethylene plus another ethylene. We are going to add another ethylene. So two ethylenes when combined together, you will get a molecule. So this is called diethylene. Diethylene. Why? Monomer. One ethylene, two ethylene. Two means diethylene. How this molecule is formed? This molecule is formed by the transformation of the bond like this. So in diethylene, two ethylenes are added. If you add one more ethylene, if you want to add another ethylene, now the bond is shifted. You have to call this as triethylene. Triethylene. If you want to add one more ethylene, now it becomes tetraethylene. Instead of tri, it becomes tetra. Tetraethylene. 5 pentaethylene. 6 hexaethylene. Like that, if you go on increasing the addition of ethylene molecule one by one, you will get a very big ethylene molecule that is called many ethylene. 1, 2, 3, 4, like that, endless. It is called many ethylene. So many, the symbol term is replaced by the Greek word called poly. Poly means many. So polyethylene. Now it is commercially, we used to call it as polythene. Polythene carry bag that we are using in our life is called polythene. So here polythene is an organic molecule because it contains carbon. It is a polymer product. What is polymer product? This is a single unit monomer, 2 unit dimer, 3 unit trimer. So addition of molecule one by one, the process is called polymerization process. So after polymerization process, we will get a product. That product is called polymer product. So this polymer product is called polyethylene. So this is almost, this compound is formed like a chain. So this product is always called as chain growth polymer product. Chain growth polymer product. So why I explain all these things? To differentiate between the two types of plastics, this structure is highly helpful to us. Here the bond is shifted, so the bond between these two molecules, in general, the bond between the ethylene molecule, the strength is very, very weak. Weak forces exist between these two. When you heat the polythene paper, it becomes soft. It can able to stretch to a certain extent. When you cool it, immediately it becomes hard. So the stretching and elongation, it is almost, it acts as a elastomer, like a rubber. So that property is due to the weak bond formation between one molecule to another molecule. I want to tell you one thing here. This type of elastic property makes the plastic an essential substance for the survival of human being. Suppose if there is a heart failure for us, nowadays everything is available. That is replacement of heart by the plastic material. Say for example, polyurethane. This is also a plastic. This is also a polymer product. So the polyurethane is act as a biomaterial. It will do a function of heart. Instead of heart, the heart can be replaced by the polyurethane. This is a highly advanced technology. Without this polyurethane, no one can able to survive. This is the recent development that we are all familiar with the utility of the polyurethane. So here, what is the importance of polyurethane? The polyurethane is a plastic. It's a thermoplastic. It becomes soft while on heating and hard on cooling. It possesses the elastic property. Like a rubber, I'll do one thing now. Sure. I want to demonstrate you the elastic property of rubber. Now, you give some force to the rubber, it will stretch like this. The rubber wants to attain its original position, see? When you relax it, it will do. So the elastic material, while applying force, it will extend or it will stretch and it regain its original position. This is the elastic property. So the same elastic property possessed by the polyurethane replaces the work of the heart. What is the work of heart? Heart pumps the blood to the total parts of the body. So there is no need to give external force. When the blood enters, assume that the rubber is a polyurethane. When the blood enters into the polyurethane, it stretches like this. Immediately it wants to attain its original position. So stretching, the total blood from all over the body will accumulate to the heart. Then during the contraction, again the blood is pumped to the total parts of the body. This is the natural, almost like a natural phenomena. That is why nowadays the heart is replaced by the polyurethane. So in medicine, the plastics act as a biomaterial. So the plastic materials can be implanted, that is plantation, you know very well. Plantation means growing the tree, growing the plant. So plantation, we are going to develop a plantation of plastic in our body. So that is called implantation. What is the use of implanting the biomaterial like polyurethane instead of heart? It will do the heart function. At the same time, it will do the medical term called prosthetic function. Prosthetic function. So the plastic is act as a biomaterial. As we discussed about the polythene, the polythene is a plastic, no doubt in it. You know, you are familiar with the another plastic, PVC, polyvinyl chloride, then PFTC, polytetrafluoroethylene. These are plastics. These plastics are the best examples for thermoplastics. Thermoplastics. See, you know, we already discussed about the structure of ethylene. This is ethylene. In ethylene, the same ethylene, here there are two hydrogen atoms. If one hydrogen is replaced by chlorine atom, now this is called vinyl chloride. Vinyl chloride. When you add one vinyl chloride to another vinyl chloride, you will get divinyl chloride. Like that, you will get many vinyl chloride or polyvinyl chloride. Polyvinyl chloride. Similarly, in the case of hydrogen, in the polyethylene or polythene, if the hydrogen is replaced by fluorine, now this compound is called tetra. Tetra means 4. Instead of 4 hydrogen atoms, here the 4 hydrogen atoms are replaced by 4 fluorine atoms. So tetra means 4. Fluorine upper tetrafluoroethylene. Tetrafluoroethylene. If many tetrafluoroethylenes are added one by one, this is called polytetrafluoroethylene. So these are all called as thermoplastics. All these plastics are formed by addition polymerization reaction. Addition of 1, 2, 3, like that, addition polymerization reaction. Okay, you are well familiar with one type of plastic, thermoplastics. Then the another type is called thermosetting plastics. Thermosetting plastics. So this thermosetting plastic, the best example is, the well familiar material is bakelite. Bakelite is the best example for thermosetting plastic. So it is also an organic high polymer because it is a plastic, no doubt in it. How this bakelite is formed? What is the basic unit of bakelite? Bakelite is formed by the combination of a simple molecule. So this is called benzene with OH. Now this is called phenol. This is called phenol. This is a simple molecule. Another one, this is called formaldehyde. So this is another simple molecule. Phenol, one molecule, formaldehyde, another molecule. When you combine these two, you will get a molecule that is called phenol formaldehyde. Phenol formaldehyde. So how it is formed? This is not similar as in the case of thermoplastic. Thermoplastic by addition, 1, 2, 3, 4, like that, addition polymerization. So during the addition you will get a product like a chain polymer product. But here there is no addition at all. Here some sort of reaction is taking place between these two. That reaction is called intramolecular reaction. So let us see what happens during this formation. You have phenol. This is another phenol. You are familiar with the position of hydrogen. It contains 5 hydrogen atoms. So phenol, formaldehyde, phenol, again formaldehyde, like that. So during this, hydrogen atom from the benzene ring of phenol, oxygen and hydrogen. So water molecule is eliminated from this structure. Water molecule is totally eliminated. But it is not similar to the ethylene. Ethylene, there is no loss of molecule, just one ethylene, another ethylene, so diethylene, another ethylene, triethylene, there is no loss of molecule at all. But we got a polymer product, there is no doubt in it. But here, we get a polymer product, but the polymer product is obtained with the loss of a simple molecule called H2O, water molecule is eliminated. So what is the final structure of the phenol formaldehyde? So this is the final structure of phenol formaldehyde. So this goes on like this. So here the product phenol formaldehyde, or simply this is called bakelite. So best examples for thermosetting plastic. Thermosetting plastic is formed by the polymerization process. So in this polymerization process, there is an elimination of simple molecule water. So here this type of polymerization reaction is called condensation polymerization reaction. Condensation polymerization. So you must make a difference between the two types of polymerization. Thermoplastic polythene formed by addition polymerization reaction so like a chain polymerization reaction, no loss of molecule is taking place here. So here we got a polymer product, but this type of polymerization is called condensation here with the loss of molecule. So I hope that you are clear about the addition polymerization and condensation polymerization types of plastic, thermoplastic, thermosetting plastics. I will show some video clippings about the usage of the bakelites. I want to tell you one thing here. The polythene cover, I already told you, can be able to expand while on heating. But here in thermosetting plastic, no expansion is possible. No expansion. It will not be subjected to heat. Suppose if it is subjected to heating, it will not expand. So this is an irreversible process. This is a reversible process. So reversible and irreversible process. So at the same time, you can reuse the polythene paper. Whatever the polythene product, whatever the thermoplastic material that you can use, you can able to reuse. Suppose this is a pen, if any damage is appeared in the pen, you can able to make the damage properly. You can able to clear, you can reuse it. So we can able to recycle this plastic, but here recycling and reusage of bakelite is highly impossible. It is not possible. Or you can say the thermoplastics, they are mostly similar to metals. They are similar to glass. So metal, if you apply the temperature over the metal, definitely it will elongate, it will stretch. So the property of the thermoplastic is similar to metal, similar like glass. No? You can give the temperature to the glass, it can expand marginally. So it also possesses the elastomer property, elastic property. Glass is also a good elastomer. So in the case of thermosetting plastic, the bakelite, it is almost similar to cement and ceramics. You know the ceramics. Ceramics, it's a tiles that we are using in our normal construction purposes in our houses. So when the ceramics, ceramics break down, definitely you can't able to reuse the ceramics. Reuse is highly impossible in the case of ceramics. So this is an irreversible process. What is the reason for this? This is formed by the condensation polymerization. What happened in condensation polymerization? Loss of molecule. So these are all the main criteria that we have to make difference between the thermoplastic and thermosetting plastic. Polymerization. It is a chemical process in which large number of molecules combines to form a big molecules. Example, polythene, ethylene, diethylene, polyethylene. Let us see the types of plastics. Plastics are classified into two types. One, thermoplastic. The other one is thermosetting plastics. types of polymerization. There are two types of polymerization reactions. One addition polymerization reaction, the another one is condensation polymerization reaction. Addition polymerization reaction, the polymers are formed by simple addition of monomer molecules to each other in quick succession by a chain mechanism. This type of polymerization is called addition polymerization or chain growth polymerization. Now, let us see the difference between thermoplastics and thermosetting plastics. The thermoplastics, they became soft on heat and hard on cooling. The whole operation is reversible. In a thermosetting plastics, they became hard on heating and cannot be softened on cooling. The whole operation is irreversible. 2. They are formed by addition polymerization. Thermosetting plastics are formed by condensation polymerization reaction. The thermoplastics are soluble in organic solvents. The thermosetting plastics are not soluble in organic solvents. Thermoplastics expand very much on heating. Setting plastics expand marginally on heating. They held together by weak van der Waals force. They can be easily broken by heating. They held together by strong force. They can be easily broken by heating. We can reuse the scrap material of thermoplastics. The scrap cannot be reused in the case of thermosetting plastics. The thermoplastics are processed by injection molding. The thermosetting plastics are processed by compression molding. The thermoplastics, they resembles like metals and glass on heating. The thermosetting plastics, they resembles like cement and ceramics on heating. Let us discuss about the mechanical properties of plastics. The first one, creep. When plastic is subjected to a heavy stress for long duration, it may undergo a change in shape. The change in shape is due to the deformation in structure. So, let us see the visual of the deformation, creeping property. Here, the load is continuously applied by me and my professor. If I do so, the shape of the plastic chair is definitely going to change. So, this type of property is called as creep. The next property is stress to strain. The stress to strain curve is not as simple as metal. Plastics can be reinforced by glass fibers like concrete. The strength to weight ratio. The strength to weight ratio of plastic is higher than that of light metals like aluminum, magnesium, which are used in rocket and spaceships. Or conductivity. We know the plastics are insulator. They can be made as a conductor by adding silver powder to resin. The next important property is elasticity. Plastic become elastomer. The TG varies plastics to plastics.
Now we are going to discuss about uses of plastics. Nylon, ropes, carpets, dresses, gear and bearing, toothbrushes. Then urea formaldehyde, cation exchanger as a bidder in glass fiber, plywood as adhesives for lamination switch, buttons, cups and radio cabinet. Then PVC, well known as polyvinyl chloride, pipes, hose, film, insulator, refrigerator, toys, raincoat and tablecloth. Then we are going to see what are all the uses of plastics in medicine and surgical fields. It is used as biomaterials. Biomaterials are polymers that can be implanted in human body to provide special prosthetic functions. They are also used for diagnostics, surgical and therapeutic applications. Examples: silicone rubber, polyurethane, PVC and polypropylene. Polyurethane, it is used for artificial heart valves, blood filters and blood vessels. Then polyvinyl chloride, it is used to make disposable syringe and medical equipments. Then polypropylene, it is used for artificial heart valves, blood filters for making sterilable medical instruments. The last one is polyethylene. It is used to make disposable syringe as a bag for storing blood. Polythene bottles are used to store medicine. So far we have discussed polymer and plastics, its properties, its applications in various fields. Now we hope that you would have better understood the contents of this discussion. Thank you very much.